we're going to move right into the first topic. So this is slang units of measurement. So I have it on full screen, so I'm going to switch it over to where you can see the paint window. And now we will get right into it. So in our society, speaking in English, although there is definitely slang in every language, in English there's a lot of sort of ambiguous units of measurement that we use. And so, first off, I want to warn any of the younger audience. This is going to be somewhat of a more um, older, mature topic, I guess. Um, so, let's get right into it then. So, what I'm going to be focusing on today is majorly categorizing and sort of putting a picture on the abstract units of volume that we use in our everyday life. So these units of volume are crap load, crap ton, and whatnot. So I'm going to be sort of just giving a general idea of what these are. So let's just list them off. We have a crap load, or a crap ton. I'm considering these to be the same thing, a crap load or a crap ton. Then we have a shit ton. And of course, after that would be a fuck ton. And so these I would claim are increasing in size. And remember, I'm talking about volume here. So these are things that people use a lot in their everyday life, everyday conversation. Maybe some people don't use the exact same language, but essentially they're the same units of measurement. So what I have decided is that I'm going to put a general, maybe not exact, but a general volume for these individual measurements. So I'm going to clear this off, and we're going to start with the first one. So we have crap load. So we have to think about what this actually describes. So if we have a crap load of something, then this usually means that this is it's something you can count. It's not necessarily a liquid. I guess you could say you had a crap load of water, but in that case, you would normally be saying that you had a crap load of water bottles or a crap load of glasses of water. So we're going to assume that these are volumes of objects that you can count. So this is a little bit different from our normal measurements of volume, which would be gallon or liter, depending on where you're at. So these measurements are exact amounts of space that would usually contain like a liquid or some sort of very fine object. But in this case, we're sort of quantifying an object based off of how much space it's taking up. So what I'm saying is that a crap load is enough to fill up a sandwich bag. So we have a sandwich bag. Now, this doesn't work in all cases. So we have our sandwich bag. It has the little plastic strips on it to connect the bag together and seal it. So I'm gonna have some variations of this. So the first definition, this is number one, is it is enough of something to fill up a sandwich bag. And like I said, this doesn't work for everything. So this would work for smaller objects like Cheetos or I'm missing an, or perhaps pennies. You could have a crap load of pennies. But this doesn't really work for larger objects. And so I want to sort of put a double definition here. So we're going to have a second definition. And this is going to be at least 12. So this, in terms of everyday speak, would be a dozen. Or perhaps you could speak in dosnal. This would be dough of the object. So you're going to see a theme with that moving on, but What's nice about the number 12 is that it's very divisible in terms of breaking up objects into individual groups. So if you had 12 eggs, you can have a third of that dozen would be 4 eggs. That's a nice even number or nice benchmark number. You could have a fourth of those eggs. That's 3 eggs. You could have half. That's 6. You can have a sixth. That would be 2, or you could have a 12th. That's 1. So there's a lot of numbers you can work with without having to get into fractions, and so that's pretty nice in everyday speak, especially with things that can't really be broken into fractions. Like eggs would be a little bit difficult. You'd have to sit there and measure out how big 1 egg's worth of goop is and then divvy it up. So this is what Jono is claiming is a crap load. So Jono's crap load. So we're going to move up a step here. And so the next step from a crap load or crap ton is a shit ton. And so the trend is that the more vulgar the language, the larger the amount of objects. So this would imply that there is a significant amount more than the initial setup. So we have a crap load, which is about 12, or perhaps a sandwich bag for smaller objects. We're going to continue the trend with that to be a gallon bag. So we're going to have a bigger bag, and so this is something that you would normally store leftovers in. It can store a lot more than just one meal, we would say. This first definition also allows you to apply this to some things that aren't as countable. So if you had some sand, I guess, then sand tends to be seen on a macro scale as opposed to individual granules. So you could have a shit ton of sand, and it would just be a gallon bag full of sand. So that's what I'm saying is our first definition. And so this is completely full with whatever object you are desiring. And of course, we need a second definition for larger objects. So we're going to follow the trend of 12, and we're going to go greater than 12 squared, which is equal to 144, or 1 grow, if you are following the Dosnell trend. And once again, 144 is very divisible, so it has all the divisors of 12, along with many more as 12 is multiplied to be larger numbers. And so this allows us to divvy up amounts into smaller groups that are still whole numbers very easily, as opposed to 100. If you tried to divide it by 3, that wouldn't really work, whereas 144 will do that fine. So a shit ton is what we're defining as either a gallon bag full of, or 144 or greater of an object. So you could have a shit ton of tanks. That would be a lot of tanks. You could probably take down a couple cities with that. Simply by rolling over it. I don't think you'd even have to fire the guns at that point. Okay, so we're going to move on up. And so we have a crap load or crap ton and a shit ton. And then after that, we have a fuck ton. Following the trend, this is slightly more vulgar. And we would say that this is a significant amount more. Well, you might be able to guess where I'm going, but I'm just going to say it anyway. We're going to get a 10-gallon trash bag of this. Now, this isn't necessarily our 12 jump in terms of volume, but we will continue that trend in the second definition. So we're going to get a nice big old trash bag, and it will have our tie over here and our tie over here. And so you can imagine if you had a fuck ton of pennies, that would be a lot of pennies. 10 gallons worth of pennies. I don't know if anyone wants to try and do the math on how much money that would actually be worth, but it would be a significant amount of money, although it would also be significantly heavy, and very much a nuisance when you brought it to the bank for conversion to actual usable currency. Um, if we keep going to our second definition, we can continue the trend of 12 to the 3. I'm blanking and I'm going to have to pull out my calculator for this. Uh, it is 144 times 12. So 12 times 12 times 12 equals 1,728. I knew it was a 1 7. 1,728 objects. And so you can imagine that if you put pennies into a 10-gallon trash bag, there would be more than 1,728. But if you had perhaps, I don't know, helium balloons that were inflated, you couldn't really fit 1,728 balloons into a trash bag. But if you wanted to have a fuck ton of balloons, you would have to go up, and I mean up as in the movie. You would have to have a significant amount of balloons. I don't know what the upward force would be generated by 1,728 helium balloons due to buoyancy, but you can figure that out in your free time. Now, there is something I want to mention that is a little bit interesting about the slang units of measurement, units of volume. Now, in real scientific and empirical measurements, we have the empirical system, which is a little bit frowned upon in the science community, and the metric system. And what's interesting is when we have the conversion of the equivalent metric unit to a empirical unit, we actually see that most of the equivalent units of measurement are smaller on the metric side than the empirical side. So in empirical units, we have an inch as our sort of small base unit, and that would be a centimeter in metric, but this is actually, it takes about 2.54 centimeters to make an inch. Moving up from that, there's a foot, and people may not know this, but there's actually a decimeter. It's 10 centimeters, which is significantly smaller than a foot. So the one exception that I can think of off the top of my head is that a yard is actually smaller than a meter, which is 100 centimeters. But that's kind of cheating because there's 36 inches in a yard and there's 100 centimeters in a meter. But that's just how the metric system works. It's base 10. So this is the special one. And then we have obviously a mile, which is significantly larger than a kilometer, and so on. This continues into volumetric units. So if we have a gallon, this is larger than a liter. A liter is actually a decimeter cubed. So that's a fun fact for you. But you see the trend, so that the metric system based units tend to be somewhat smaller than the empirical system's base units. So what's interesting is that this isn't necessarily true in these abstract units of volume. So if we have a shit ton, then we've established that this is about a gallon bag, or at least 144. But if we have a metric shit ton, then the interesting idea is that because this is more words, it actually seems as though it's emphasizing how much there actually is available. So I would claim that a metric shit ton is exactly 1.2 times a shit ton. And so this is a 20% increase, or a baker's dozen. It's also 1.2. That's actually just a coincidence when I was thinking this out. But This would continue into a metric fuck ton or a metric crap load. Although metric crap load doesn't really have the same ring, I would suggest a metric crap ton because a metric ton is an actual thing. So metric crap ton seems as though it would be an actual thing. So this is my general categorization of these abstract volumes. And so what I want you to do is to spread the awareness, because I feel as though people use these so willy nilly that they don't necessarily understand what is the actual amount, and it tends to be somewhat of an exaggeration when they use these units of measurement. But I think, being the engineer I am, it's important to have standards. And even with abstract concepts such as a metric shit ton, there should be a standard, or at least a range of understood value to those words. So um, that is what I'm getting at. And there is one more unit of volume I want to mention. This follows the trend of units of volume that actually measure numeric value. This is a canoe. And you may say that's not a unit of measurement, that's a boat. Well, it is a man-powered boat, and it is generally about the same size every single time. So now there are some differences. Sometimes you have 16-foot canoes, maybe even longer. If you get to the dugout canoes that the Native Americans use, they can be extremely long. But generally, we're talking about our I'm going to go to a campsite and rent a canoe for the day kind of canoe. So if we have a canoe of people, then how many people would that be? Well, a canoe, in terms of people actually paddling, would be about two people, but a canoe can also hold a couple more passengers. So comfortably, a canoe could have three people in here, where two people are in the seats and one person is being the lazy bum in the middle but does not have a seat, so they are slightly less comfortable. It's a reasonable trade-off. But if you really want to push the possible carriage of a canoe, you could throw another person in here. Now, the warning labels will probably tell you not to do this, but it is possible. The canoes have a reasonable factor of safety in terms of flotation, because of these air pockets up in the front and back. You can actually fill the canoe completely with water, and it will still be paddleable to where you can bring it back to shore. Um, so if we say that a canoe is about 3 to 4 people, then we can use this in the similar way that we would use our other abstract units of volume. So a canoe worth of PB&J sandwiches would be probably a metric fuck ton of PB&J sandwiches. Actually, I want to take that back. It might be about half a metric fuck ton of PB&J sandwiches. If you had golf balls, I would say that would easily be a fuck ton, if not a metric fuck ton, of golf balls. So you get the picture here. This is something that you don't necessarily need to raise awareness for unless you actually feel necessary. But I feel as though a canoe would be a very interesting abstract unit of volume. There are other units of volume that have been used in the scientific community. I saw that Randall Munroe on XKCD actually measured the volume of I'm sorry, I'm like the volume of the rockets that have been to space with horses. I think this was a jab at the idea of claiming that something has horsepower, even though it's a very it's a very specific number now and not actually the average power of a horse. But it was saying that he was saying that you could measure other things with having horses as your base unit. So that's all along the same vein. This is the general topic that I wanted to talk about for abstract units of measurements, and I think I'm going to be moving into my second topic, which is the 4-bar linkage using analytical method or vector method, as I would say. So if that interests you, keep watching. I'm going to have a random drawing at the end, so stay tuned for that. But if you've been watching this far, I want to thank you guys for coming out,